In this question, they said at 25 kVA, so write it down side by side. S is equal to 25 into 1000 VA. Okay, you need to convert it into standard unit. So V1 is equal to how much? 2000 volt. V2 is equal to how much? 200 volt. Then they mention core and copper losses at full load. Full load means X is equal to 1. Core losses is denoted by PC 350 watt and copper losses are 400 watt. Okay, then they asked us to calculate the efficiency at full load. So efficiency formula is x into v2 i2 cos phi 2 divided by x into v2 i2 cos phi 2 plus pi plus pcu, right? So in this case they said UPF. UPS stands for unity power factor. So unity power factor means cos phi value is equal to how much? 1. And full load, they said full load means 1. So x value is 1. V2 I2 they have given you directly in the form of power, that is 25,000. Cos phi is also 1. We can mention the same values. Pi is given, so we should mention x square PCU also. X is again 1. Pi value we know, Pi is equal to PC only, right? So after calculating the values, we'll get the efficiency is approximately 97.08%. Okay. In the next case, they are asking the at half load with unity power factor. So in the next case, half load means x is equal to 1 by 2, and they said the unity power factor means cos phi value again it is equal to 1. All the values are same, we just need to change the x value. Just remember it is x square. Okay, so it would be 1 by 2 square, that is 1 by 4. Maximum students will do mistake here only. Okay, so if you'll solve it, then at half load you will get efficiency 96.52%. Okay, next they are asking the maximum efficiency at unity power factor. As you know that for the maximum efficiency, what is the condition? That is iron losses must be equal to the copper losses, right? Or we are having another formula, that is Pi is equal to x square PCU, x is equal to root of Pi divided by PCU, right? So they said we have to calculate maximum efficiency, means in this case we need to consider iron losses must be equal to the copper losses. Okay, so iron, whichever losses are less, we need to consider that one. In this we can see that iron losses are 350 watt. Okay, so we'll mention iron losses also 350 watt. We'll mention copper losses also 350 watt. Okay, rest of the things are same at this at as they said that unity power factor means cos phi is equal to 1. Okay, cos phi again 1, but we don't know about the x value, right? We don't know about the x value, but x value we can calculate it by this formula. X is equal to root of Pi by PCU. Root Pi is how much? 350. PCU is how much? 400. From here we can get it the x value. We can simply put in this formula, right? Any doubt up to here? You can calculate it also. Okay, and you know the formula for the maximum normal efficiency. So after solving it, x is equal to root of Pi by PCU, that you can get it. V2 I2 is same 25,000. Cos phi they have mentioned 1. Pi is 350 and PCU is 350. Okay, from this we'll get the maximum efficiency as 97.09%. But we need to calculate the D part. D part is copper loss at maximum efficiency. Okay, means they are asking the copper loss at maximum efficiency. Now you know that x is equal to root of Pi by PCU. So we can put it in this formula, like we'll get the maximum efficiency maximum, x is equal to V2 I2 cos phi 2 divided by again x V2 I2 cos phi 2 plus Pi plus x square PCU. X x value we got it from that formula, Pi root of Pi divided by PCU, right? V2 I2 we know, cos phi 2 we know, Pi we know. We only need to calculate copper losses. Now we know about the maximum efficiency also, right? in the previous C part, we calculate the maximum efficiency as well. We are having all values, we just need to calculate copper losses. We can easily calculate it, and after solving it, you will get the 350 watt. I told you that iron losses and copper losses are equal, so it would be 350 watt. Okay. Next, they are asking load at which efficiency is maximum. Means simply they are asking the x value. X is that we already calculated, that is x is equal to root of pi by pcu. Pcu we already know, we can substitute it. Then we'll get the load at which maximum efficiency is maximum. Okay. And if they want us to calculate the power, we can also calculate the power. Okay, clear this question?